Hello everyone, this is Dr. Irfan Kamruddin Andani. In our previous discussion, we discussed that how to apply couple and how to have some control over the root movement when using fixed appliance. In this presentation, we will discuss that how to calculate moment of couple and how to achieve various kinds of tooth movement apart from tipping. When you want to calculate the moment of couple, the formula is very simple: force into the distance between the point of force application. Here, if the width of the bracket is 5 mm, then the distance between the point of force application is also 5 mm, since the wire is in contact at the edges of the bracket slot. If applied force is 50 grams, then the moment of couple would be 250 gram millimeter. Is this formula different from that what we learned for the calculation of moment of a single force, which was force into force arm? No, it's the same. If you calculate moments of both the forces in this couple separately, you will get 125 gram millimeter each side. Adding both, the answer will be the same, 250 gram millimeter. Now the second question is how to achieve movements other than the tipping. The answer is very simple: by managing the ratio between the moment of applied force and moment of couple. But things are not very simple. Look at this table you can find in most of your textbooks, which gives you the ratio between force and moment of couple to achieve particular kind of tooth movement. Like for tipping, it is 1:0, while for translation, it's approximately 1:10. But here I want to clarify it more with the following example. For instance, this is the case of class 2 division 1, and you have planned to extract upper first premolars bilaterally and finish the case in class 2 molar relationship and canine in class 1 relationship with normal overjet and overbite. After a sequence of wires, you have reached to a heavier wire and you have started to retract the canines with the use of power chain. Now let's assume that how does this canine react to the applied force? Since there is just a single force of power chain, canine will initially tip distally and there will be simple tipping in the direction of the force. If you want to calculate the moment of this force, formula is the same: moment into force arm. If the force is 50 grams and the distance between the force application point and the center of resistance is 10 mm, then the moment is 500 gram millimeter. Till this stage there is no couple, and we know already that when a tooth is subjected to single force and there is no couple, there is simple uncontrolled type of tipping. The canine will tip till the wire is in contact with the bracket at 2 points. Now there is generation of couple. If you keep on increasing the force magnitude, the 2-point contact will not allow the tooth to tip anymore unless the wire itself is deformed and it is very flexible. Otherwise, the whole force applied on this tooth will be used to increase the magnitude of couple. When moment of that couple will be equal to moment of applied force, the tooth will move bodily, and there will be sliding of canine on the arch wire. Now you can easily understand that why do we recommend canine retraction on heavy wire, because thicker the wire is, more bodily movement you expect and there will be less tipping. In this example you can see that there was 50 grams of force applied and the couple was 500 gram millimeter. So the ratio between the force and the moment of couple is 1:10, which is a requirement for the bodily movement. If you see the table again, you can see that initially in your case there was simple tipping and the ratio between force and moment of couple was 1:0 because there was no couple initially. The other way to understand the same phenomena, you can say that there was no couple and there was moment of force which was 500 gram millimeter, and 0 divided by any number results in 0. For translation, you can see that 1:10 was the requirement of the force to ratio of moment of couple. In our example, the force was 50 grams and the moment of couple was 500, fulfills the requirement for translation, and in this formula you can see that moment of couple was also 500 grams millimeter and moment of force was also 500 gram millimeter, both were equal, then it resulted in the answer 1, and that is also a requirement for translation. Clinically, you will see this kind of movement, initially tipping and followed by translation. Now the canine is in class 1 position and you have applied crimpable hook to retract the incisors back using the power chain. Now what kind of movement do you expect? The ideal movement would be the translation of all the incisors back to correct the overjet. But things are again not very simple. Let's zoom what is happening at the incisor level. The movement of incisors will depend not only on the thickness of the wire here, but also on the cross section of the wire. Since the cross section of the bracket is rectangular, no matter how many rotations you give in a round wire, there will be no generation of couple. Because you know that to open a nut bolt, you need a wrench of equal shape and size. Therefore, to achieve control over the root movement and to generate the couple, you will need rectangular cross-sectional wire, and luckily we do have that. Placing the rectangular wire in rectangular bracket slot and giving some twist in the wire, you can have 2-point contacts and the generation of couple, and in this way you can have some control over the root movement. Now the type of movement you will get from the mechanics depends on the amount of single force you have applied to retract the tooth and the magnitude of the couple you have generated here. Now this also should make some sense to you that if you are retracting incisors on a round wire, there will be just retroclination of the tooth. Since there is no rectangular wire, there will be no couple. If you want to calculate the moment of this force system, if you have applied force of 50 grams and the distance between the force application point and the center resistance is 10 millimeter again, then the moment of force would be 500 gram millimeter. Is there any couple here? No. Therefore, there will be simple and uncontrolled type of tipping, in which force ratio with the moment of couple is 1:0. The single force you applied here was 50 grams and there is no couple, so it resulted in simple type of tipping. Instead of round wire, if you have given rectangular wire and also given some twist in the wire to achieve 2-point contacts and generate couple, there will be some control over the root movement. Now the movement will depend on how much twist you have given in this wire. If by twisting the wire you have generated moment of couple around 350 grams millimeter, there will be control tipping. For control tipping, moment of couple is not 0 and it also should not be equal to moment of force. Therefore, in this example, it was around 0.7. And if you want to calculate moment to force ratio, then it is 1:7, because the force applied here was again 50 grams and moment of couple was 350 grams. It makes the ratio of 1:7, which is a requirement for control tipping, in which center of rotation is at the apex. Assume that you have given more twist in the wire to increase your force value, which has increased moment of couple more. And when moment of couple is equal to moment of force, there will be translation. But the question arises here that how much force you have to apply through this couple to achieve moment of couple of 500 gram millimeter. The formula is same for that. To calculate moment of a couple, you have to multiply the force magnitude with the distance between the point of application of the force. Here you can see that wire is in contact with the bracket slot at 2 points. So the distance between the point of force application depends on the height of the bracket slot. In this case, I have taken 0.45 millimeter if you are using the bracket system of 18 mil. If you are using the bracket system of 22 mil, then this distance would be 0.55 millimeter. And putting that value in the formula, and we have to achieve moment of couple of 500, you can derive the amount of force required to achieve this magnitude of couple. For 18 mil, you will have to apply force of 1100 grams to achieve moment of couple of 500 gram millimeter. And if you are using 22 mil bracket, then you will have to apply around around 900 grams of force to achieve the same amount of moment of couple. If you want to see the ratio, here the force we used was 50 grams and the couple was 500 gram millimeter. So it resulted in translation of the tooth. For example, if you have given more twist in the wire, what is gonna happen? It will also increase the value of the couple from 500 to maybe 600 grams millimeter, and that will result in more of the root movement. We call it torque. Here the moment to force ratio is 1:12, which is a requirement for torque. The center of rotation has shifted towards the crown. If you have given more twist in the wire, and the moment of couple has increased up to 800 grams millimeter, then there will be pure torque. And if you remember from your basics that whenever you apply just couple, the center of resistance and center of rotation both are at the same point. The ratio between force and moment of couple is 1:more than 12.